Hello and welcome back. We have understood what is regularization, then we actually practically seen how to use it in real time. Now let us try to understand different kinds of regularization: ridge, lasso, and elastic net. In the ridge, the regularization term adds the L2 norm. We call it as L2 norm, right? When the ridge regularization is applied, even though some features are not important, the thetas will not become zero. Completely zero, it will never make. Or until and unless the feature is extremely not important, it will not make the coefficient to zero. It will keep some number, maybe 0.0001, something like that. Okay. Now, when you know that the model's accuracy is dependent on all the features, little bit is power is being added by all the features. You generally apply ridge. Our general default is ridge only. Generally, we don't go with lasso. But in Lasso, it tries to eliminate all the features which are not important by making the coefficient zero. Right? It actually makes even if the feature is a little bit important, also it will not consider, it will eliminate. You need to apply Lasso only when you already know that only certain number of features are adding importance in predicting the target variable. So most preferred is ridge. When you already know only some features are important, then you can apply Lasso. But if you don't know, right, then you can apply elastic net. It's a in between, right? It's a middle ground, right? If you look at the cost function, we have added lasso regularization and ridge regularization both by using a balancing parameter or mix ratio. In our code example, it is called as L1 ratio, right? So if you make this zero, what happens? It's R0. Then it completely becomes lasso, ridge, because 1 by 2, sigma by m, whatever this term remains, because r is equal to 0 here, this term will vanish and only this term will remain. It becomes ridge. If you make it 1, it becomes lasso. If you want in between, you put 0.5, 0.0, 0.5, then it is half a lasso and half a ridge. So sometimes it may brutally take out some features by making their coefficient zero, and some it will consider something like that. If you put this ratio more, it works like maybe 0.9. It works more like lasso, less like ridge. If you put 0.1, less like lasso and more like ridge. So you can play with lambda and r and make the model work best on train set and test set both. So this is the theory about the theory and practical examples about the ridge and lasso regularization. But in scikit-learn we have got classes to implement it, right? The elastic net, lasso, and ridge. We would suggest you to go through the API for this elastic net and ridge lasso and try to experiment. But with no, with the SGD regressor itself, you can do everything because the L1 ratio is the R, and penalty you can give either L1, L2, or elastic net. Okay, so with the SGD regressor itself or SGD classifier itself, you can do. So we'll if when you get time, right, you play with these. So that's it on regularization. Thank you.